Now I'm going to build the electronics stack for the OHMMM robot. Here I have the modified orangutan board. I have the mezzanine laser cut plate. I have the Y power board, which is an off-the-shelf board, 2 power inputs and 1 power output, and it switches among the inputs to select the one with the higher voltage, gates that to the output. The Y power board comes with some connectors, including this cable here and these two, which we'll be modifying. I've got 2 Tamiya full-size female connectors with pigtails from Palulu. I've got 6 pieces of 3/16 heat shrink tubing pre-cut to 3/4 inch lengths. That's a product from DigiKey. I've got 3 pieces of 1/2 inch heat shrink tubing that I cut to 1/2 inch lengths, and I've got 2 1/4 inch long male to female 440 hex standoffs, 2 440 by 3/16 long screws, and 2 440 washers and nuts. All of those are going to be associated with the Y power board. For the fuse setup, we have a through-hole PCB mount fuse holder. We have a 3 amp automotive fuse. We have 4 256 by 3/8 long screws. We have a 3D printed clip for the fuse holder. We have a 6 inch length of black and red, as well as a 4 inch length of red 20 gauge high flex wire with silicone insulation. We have 2 pieces of heat shrink tubing. These are, I believe, 1/8 diameter. So that will be for the fuse. We have the reset switch here with 2 1x1 0.1 inch housings and 2 female crimp connectors for those housings. 1 piece of 332 heat shrink tubing. This heat shrink tubing here for the fuse was also 332, not 1/8. So we have another piece of 332 heat shrink tubing for the reset switch. 2 6 inch lengths of 26 gauge hookup wire, yellow and black. That's for the reset switch. We have the power switch, which is a double pole, double throw panel mount switch with a bit of red, black, blue, and white 26 gauge hookup wire, about 4 inches of each. 2 more pieces of the 332 heat shrink tubing. All of these pieces of 332 heat shrink are 1/2 inch long. They come from DigiKey pre-cut like that. And then a few more mechanical bits. We have 4 440 female to female round standoffs that are 1.25 inches long, and 4 440 by 3/8 screws that will hold the mezzanine plate. And then we have 4 256 by 1/2 inch long hex standoffs, male to female, with 4 256 by 3/8 screws, 4 256 nuts, and 4 256 lock washers. So I'll get started with some of the mechanical bits. First I'll do the standoffs, the 440 by 256 standoffs, which I will attach to the org board using the lock washers and nuts. And just tighten those finger tight. The standoffs are made of aluminum, and it's not too hard to actually strip the thread, so be a little gentle. Okay, those are the standoffs for the org board now attached. And just so I don't lose them, I'll temporarily thread in the 256 by 3/8 screws into the bottom of those standoffs. Now I'll also attach the standoffs. These are 440 standoffs to the bottom of the mezzanine board. So orient the board like this so that the hole for the reset switch is in the upper right, and these are the landings for the external USB connectors for the Panda, and then the standoffs go in that corner, this corner, that hole there, and that hole there. Like that. Okay. Now I will assemble the reset switch. And the power switch. And I orient that switch so that its 6 terminals are oriented that way. Tighten that up. And now I'm going to leave that board turned over. For the Y power board, we'll call this the top of the board. We'll actually insert the 2 standoffs with the male end coming up from the bottom. Slip one of the lock washers and a nut over that and tighten. So these are 440 by 1/4 inch long standoffs coming out the bottom of the Y power board through its 2 mounting holes. And so I don't forget, I'll just thread those screws in there. And it's a little tricky to find the correct holes. It's that one and that one there, so, and it goes on with the 2 inputs facing out. Grab a screwdriver. So that's the mezzanine right side up. Turn it back over. Now I'll work on the electrical inputs to the mezzanine. We'll take these two provided adapters that came with the Y power and clip off the DC barrel jacks, which we won't be using. Instead, we're going to attach on these Tamiya full-size female connectors, which will provide two inputs either to the battery or to the AC supply. So I'll strip these free ends now. Just a small amount, a 1/16 of an inch, an 1/8 of an inch. Tin the connections. Now I'll take my Tamiya connectors and I'll slip on the heat shrink tubing. This is 3/16 diameter heat shrink tubing, pre-cut to 3/4 inch lengths. And I will connect these together with red going to white and black to black. In a moment I will shrink that heat shrink. Now for the output of the Y power board, we'll take this. This is a provided jumper cable with the Y power board, and we're not going to use the whole thing, so I'm just going to cut it about 1.5 inches on, and here the yellow wires are the positive voltage and the black will be the negative. I'm going to strip all 4. And I have my 6-inch piece of black 20 gauge and 4-inch piece of red. I'll strip those as well. Now I will tin and connect the blacks together, and then the yellows to the red. Bit of flux on everything. And I'll seal those with the remaining 3/16 heat shrink tubing. Okay, now I'll attach these to the Y power, and to help prevent them from coming off, I'll slip on these 1/2 inch lengths of 1/2 inch diameter heat shrink onto each connection around the connector, sliding it between the connector and the board. It should go. This is the output side of the Y power. And a little trouble getting that on there. There we go. These are polarized connectors, and they do have a locking mechanism, but what we found is that because they're square connectors, it is possible to insert them 90 degrees rotated, which can cause a short. So we don't need to normally allow them to be disconnected, so that's why we're going to heat shrink that down to help prevent the possibility of that kind of short. These are the two inputs. Those will get the pigtails we created that have the Tamiya female connectors. That one's a bit tight. And the heat shrink is not to insulate, but rather to help prevent the connector from being disconnected. So it actually holds the latching mechanism shut on the connector. Now I'll shrink those. This one's a little pinched. Fix that up before I totally shrink it. There we go. Okay, so those are the power inputs and outputs of the Y power board. Now I'll work on the fuse. So for the fuse, it'll be attached to the top side of the board here. So I'll thread the output of the Y power up through the mezzanine board there. This is the positive output. And then I'll take my remaining 6-inch length of 20 gauge and go up through, actually that was the wrong hole. I should be using these two larger holes there. Like that, and strip those wires, and in this case I'm going to strip about 1/4 inch so that I can solder on both terminals of this fuse holder. Flux and tin these leads. Now solder on the fuse holder. So that's one side. Trim off, there's a little extra here. Notice that I'm doing this with the wires already through the holes on the mezzanine board. And again, this fuse holder is going to attach to the top side of the mezzanine board. That's ready to be attached. I'll take the fuse holder clip, and we can first insert the fuse holder into the clip and then set that down and come up from underneath. Slight design flaw here in that there's 4 256 screws to be inserted, but the fourth one we would have to remove the Y power board to attach it, so I'm just going to skip it. We'll just use 3 screws. So these are 256 by 3/8 screws to hold the fuse holder onto the mezzanine board. The screws are going up through the underside of the mezzanine board. And into the fuse clip holder. And I can put the fuse in now, but usually we'll wait until the robot is mostly ready to be tested, and then we'll check all the connections before we provide the fuse. So this lead will provide the positive voltage to the org board, the orangutan board, and this lead will provide ground. And the connections on the org board will be will be over here. So I'm going to thread that under the Y power, and the same with this. And I'll just stow that bit of extra under the Y power as well. Make sure those are a little bit out of the way of these rows of through holes on the Y power, because we're going to be soldering to those in a minute, some of those. so the two leads can come up through this notch here, and then I'm going to prepare these leads by stripping them, tinning them, and applying some heat shrink to them. Here again I'm going to strip a little bit long, about 1/4 inch. These will have to go into screw terminals on the org board. I should have applied flux. Of course, there's some flux in this solder. It's rosin core solder. Just remove a little bit of the extra solder here. Take these pieces of 332 heat shrink, and leaving just about 1/8 or so of an inch exposed of the conductor, shrink this on to give it some additional mechanical integrity. This one moved a little bit as I shrank it, so I'm going to strip off just a hair on that heat shrink. A little bit tricky to do. There we go. Okay, and that just gives some additional mechanical integrity to avoid stress fractures when we screw these on to the org board. Alright. Now I'll work on the reset switch. For the reset switch, we're going to take these 26 gauge black and yellow wires. I'll strip both ends, but only tin one end. On the untinned end, I will crimp female header connectors. Again, this is for the reset switch. Which will effectively connect to the org and reset the org. It's actually the emergency stop switch, which resets the org. So I just start the crimp with my needle nose. And then I'll finish it with my crimping tool. Just squeeze until the tool self-releases. and then I will form these up a little bit more. And I will take my two 1x1 headers and insert these in the correct orientation into those headers. There we go. And I'll solder these onto the bottom of the reset switch, but first I'll take this piece of 332 heat shrink and cut it in half. It's a ½ inch long to start with, so I'm making 1/4 inch pieces, and rest those on each wire. Okay, now we're going to solder these onto the reset switch terminals. So I'll tin those terminals. While I'm at it, I'll tin the power switch terminals because we're going to do that next. Back to the reset switch. Doesn't matter which side, of course. It's just a push button switch, single pole, single throw. Slide my heat shrink down well over the terminals. Mainly it's going to function as a strain relief, and then I'll shrink that. And then these two leads I will feed up through this access hole next to the reset switch. They're going to connect to the underside of the orangutan board. Okay, now the power switch. So another advantage of the Y power board is that it gives us another opportunity to have a soft off, and that's what we'll be connecting up this double pole, double throw switch to do. So I'll strip both ends of my black, red, blue, and white wires. I'll tin these wires. Of course, I don't want to actually connect them together. Now I'm going to reorient the. We're looking at the mezzanine board from the bottom side. I'll reorient it this way. And we'll connect these wires up to the bottom side of the switch. So we'll start with black. Just going to go to the left rear terminal here. Then red to the right rear terminal. White to the left middle terminal. And blue to the right middle terminal. Got two pieces of 332 heat shrink here, ½ inch long each. I'm going to cut them in half again so that we get 1/4 inch pieces. Slide the 4 pieces over those connections. This will both insulate and give some more mechanical strength to avoid broken wires. Okay. Okay, now we have to connect these to the appropriate pads on the Y power board. So the red wire will go to the this is the H1 strip, that's the H2 strip. So we're going to go to the H1 strip pin 1 with the red wire. The way I'll do this is I'll tin that pad first. It's a through-hole pad, but I don't actually have to insert the wire through the hole if I don't want to. There's my red to pad H1. Then blue will go to pad H9, the last pad in the H1 pin 9, that is. This is blue. Do this so you can see it. So we're going to go there. So red to H1 pin 1, blue to H1 pin 9. Black will go to H2 pin 3. And in a moment, white will go to H2 pin 9. Those are just low current connections that will switch the MOSFETs on the Y power to cut power from both of the input sources to the output. So that's the connection of the power switch to the Y power board. Finally, we can attach the org board to the mezzanine. So I'll remove those 256 screws temporarily. I'll make sure my orientation is right, so it's going to go on like this. To start with, I'll hook up the reset switch. And so the reset switch connects to the ground terminal that we soldered on to the underside of the programming connector, and the line marked reset on the header we installed on the reset jumper. Turn this back over. Set it in place and install the 4 screws. Things are neat. Just pull some of that. Okay, so there's the org mounted onto the top of the electronic stack. And then finally we can hook up the 2 org power leads. If you look on the underside of the org, those screw terminals are labeled. The very first one is plus and the second is ground. So the one closest to the right side here is plus, and then the next one in is ground. So taking a small screwdriver, I'll fully unscrew those and then connect up our 2 power leads. Now since we applied solder here, these are a little bit thick. I'm just going to clamp down on them with the flat part of my pliers and thin them out a little. A little too wide now, so I'll clamp the other way. There you go, so there's the plus connection. and ground similarly. Tighten the screws. Double check, plus and ground. Okay, so that completes the electronics stack.